First of all, I'm Mahmoud Said, first year medical student in the University of Carolina, Faculty of Medicine. I'd like to thank you for letting me give this presentation, this great conference. Today we're going to talk about the management of Alzheimer's disease using neural cell transplants. And this is a literature review that I did with my colleagues Mohammed Sain Ismail and Abdurrahman Sain Ismail. So what we're going to talk about today, first of all, the etiology of Alzheimer's disease and the pathogenesis of this disease. Then the study objectives, why we did conduct this literature review, and the methodology used. Then we're going to review the different neural cell transplants that we included in this study. And finally, I'm going to mention the conclusions and the recommendations. So first of all, Alzheimer's disease was discovered in 1911, so it's a very early discovery. And despite this fact, until this day, there is no current treatment for Alzheimer's disease. And Alzheimer's disease represents the major type of dementia, which is memory loss, with a ratio ranging from 60 to 80% of the present current cases of dementia. And it's pretty dangerous and outraging because the cases in 2013 were estimated of about 35 million people worldwide. And this number is about to get to 66 million people in 2030. And of course, as I just mentioned, there's no effective treatment found till the present time. So what is the pathogenesis of Alzheimer's disease? Well, the main cause of Alzheimer's disease is still unknown until now, but the current outline that we have is that Alzheimer's disease is a progressive neurodegenerative disorder, and the main characteristic of the disease is the loss of cholinergic neurons, and this leads to the formation of two kinds of protein formations like beta amyloid peptides and tau tangles or neurofibrillary tangles. These are the main characteristics of the pathogenesis of the disease. So the study objectives. We reviewed the current available neural transplants or operations that are related to the cognitive impairment caused by the induced neurodegeneration of Alzheimer's disease. And this is more kind of diagnostic because it's all preclinical. This is not conducted clinically yet because these cells, neural transplants, they are actually used in suppressing the increase in the formation of beta amyloid peptides and tau tangles, and accordingly they reverse the cognitive impairment, restoring the ability of the animal or the subject in the preclinical test again. So the methodology, we conducted a thorough research about PubMed, SpringRelink, and ScienceDirect, and the review restricted to preclinical trials that were conducted on animals, such as mice or finches or birds. And the neural transplant modalities used were, there are 5 modalities: the neural stem cell transplants, the bone marrow-derived mesenchymal stem cells, embryonic stem cells, fetal hippocampal cells, and genetically modified hippocampal cells from genetically modified mice. So, first of all, the neural stem cells transplants, as this was applied on mice, and the neural stem cells were in solution, and they were injected into lesion subjects of mice. This actually reversed the lesion effect because the lesion induced the cognitive impairment in the hippocampal area, the cortical area number 1, the CA1. And when the neural stem cell solution was injected, after trials conducted on mice like Morris water maze, for example, the animals performed much better than the control group, which received the placebo injection. We have also the bone marrow-derived mesenchymal stem cells, and these were taken from the tibias and femurs from the embryonic mice, and they were cultured, and then they were injected into rats or mice that were impaired due to toxication in the hippocampal region again, and they actually performed and gave very good results. Also, we have embryonic stem cells, and this was conducted on finches, and so the stem cells were taken from the finches at an embryonic stage, ranging from embryonic stage the day 6 to day 11, and the best results were found to be at the middle stage, like from embryonic day from 7 to 8, and also they reversed the lesion effect. Also, we have the fetal hippocampal cells. These were taken from the fetuses of the hippocampus of also other finches, and they gave very good results. Finally, we have hippocampal cell transplants of genetically modified subjects, and these were H3DB cells with fluorescent effect, so that when they are injected into the subject, they will be easily monitored. And they were injected into lesioned hippocampal area, the C1 that we see in the picture, of mice, and also they reversed the cognitive deficit. So the conclusion that we reached at the end of the literature review is that the current stem cell transplants are actually capable of suppressing the beta amyloid peptides and plaques accumulation, and that they are able to reverse the cognitive decline, and that neural transplants could offer new hope regarding the management of Alzheimer's disease. So the recommendations is to recommend further research in this field and to move it from the preclinical phase to the clinical phase, because of the good and results that actually give us hope to find a cure to Alzheimer's disease that apparently doesn't have a cure until now. And thank you very much for listening. If you have any questions, I'm willing to answer.
Oh, I already have. Your colleagues looking at attention, yes, as a comment.
Yeah.
What you really all your colleague is quite nice. It's okay for you to do an initial study.
Yeah.
For just reference, if you do a review, you have basically two types of review.
Yeah.
A simple review and a systematic review. What you did is a hybrid between a systematic review and a standard review.
Okay.
My previous recommendations were to a systematic review. So if you want to look into the databases again and check for review articles.
Actually, they are pretty much recent. They are 2008, 2009, they're 2013. And just for the finches, the experiments conducted on the birds, these are a little bit old, we can say. It's 1999 or 1998, just this one. But the other four experiments, they're pretty recent. And this is just for the neural cell part, neural cell transplants part. But the other part of the literature review related to the etiology and pathogenesis, they are pretty recent. I actually used the word Alzheimer's report 2013, and yeah.
I was going to ask you about the years you took in your research. I was just going to point out that if you want to go to another conference and present a similar paper, you should go for a systematic class or systematic review.
Can you just explain it a little bit?
In a systematic
the
review,
difference?
you have inclusion criteria for the studies.
Yeah.
This is just basic learning. You have the criteria on which you take on the studies, as you have only the prospective ones. You have a time frame. So you say, okay, I started looking back from 1962 when PubMed was founded, and I ended my search.
Yeah, so declare that in the presentation.
You have to clear that in the presentation.
Okay.
Okay.
Yeah.
Yes, you always cite the studies. Again,
and I
it's,
see.
it's customary to have some sort of a table with all the study names and
the results.
Exactly. Yeah.
Yeah.
So this is just a part of explaining your data.
Okay.
Otherwise, the presentation is very nice,
Yes.
but
Thank
it's
you
like
very
a
much.
lesson, not like a review.
Exactly, and you have to do it like a scientific paper with results. And when you have the results, you have the results of the study, which are, properly.
I already have the results, but I didn't put it. Yeah. Okay.
For the next
Yeah.
So it should be.
congress.
Yeah. Okay.
Yeah.
Thank you very much.